In this presentation, we're going to talk about weather and how clouds and precipitation are formed. Precipitation is formed in two different ways, collision coalescence and aggregation. In collision coalescence, droplets need to be 20 micrometers or larger to be able to fall and collide with each other. The larger they are, the faster they will fall. These droplets also need to be big enough so that as they fall to the surface, they don't evaporate. This process can create precipitation in the form of rain, drizzle, freezing rain, and sleet. Rain is when water droplets that fall to the Earth's surface. Freezing rain is rain that falls but freezes when it hits the surface. Sleet is rain that falls but freezes before it hits the surface. In aggregation, the process calls for ice crystals in supercooled water. This allows the ice crystals to grow rapidly and to connect to other ice crystals. This process creates precipitation in the form of snow, rain, and hail. Snow is ice crystals that fall after being formed in the atmosphere, where the temperature is below freezing and remain below freezing before they hit the ground. The rain in this process is formed when the ice crystals fall but melt as they fall before hitting the surface. Hail is created when a high updraft in the freezing atmosphere causes droplets to get taken up further and collide with others, forming hailstones. 4 different types of lifting air. Orographic lift is when air is forced to rise over a mountainous barrier. In convergent lift, a pile of horizontal airflow results in an upward movement. Air is going to flow from 2 different directions and collide with each other, forcing them to go upward. In convective lift, an unequal surface heat causes localized pockets of air to rise because of their buoyancy. Warm air is going to be more buoyant than cooler air. Frontal wedging is going to be kind of like orographic lift. Masses of warm air are going to collide with a mass of cool air. The cold air is going to act as a barrier, like the mountain will in orographic lift, forcing the warm air to rise above it. As air moves upwards, it tends to cool at about 5 to 10 degrees Celsius per 1,000 meters, known as the adiabatic rate. Once the air cools, the dew point temperature saturation is reached and therefore condensation occurs. 5 degrees Celsius per 1,000 meters is the adiabatic rate, where air saturation is reached. 10 degrees Celsius per 1,000 meters is the dry adiabatic rate. The unsaturated air parcel will rise. Once it reaches saturation, it'll become the wet adiabatic rate.